exercise is one of the most important aspects of our daily lives. Even we live in the hustle and bustle of Hong Kong, we should squeeze out some time to do exercise in order to maintain our health. We can understand our body condition by measuring our heart rate or blood oxygen content. However, do you know it is able to evaluate your health from lung capacity? You may have relatively low lung capacity if you seldom do exercise, and the following issues may happen to you.
Wait, this is no good. I have to stop running now.
Just keep running. We have only been running for around 15 minutes.
I literally can't breathe.
Oh no, you just sound like an old man with more lung capacity. Let's get a breakfast.
Sure. So, what do you mean by lung capacity?
It refers to the volume of air associated with different phases of respiratory cycle. Also, it can be divided into tidal capacity and vital capacity. Tidal capacity is the volume of air normal inhalation and exhalation when extra effort is not applied. And vital capacity is the volume of air that can be expelled during a forced exhalation after a maximum inhalation. The lung capacity of a human adult female is around 4 liters of air, and that of male is about 6 liters. It is possible that doing exercise can increase lung capacity.
Oh, that sounds interesting. But do you have any proof? I don't want to read a bunch of facts.
Maybe we should do an experiment together.
Sure. Let's pick up our belongings first.
Let's go. We can conduct an experiment to investigate whether exercise, particularly aerobic exercise, can increase lung capacity. Also, by gathering information, we can find out if there is relationship between height, weight, gender, and lung capacity.
So, in this experiment, we used the balloon method. First, volunteers needed to stretch a round balloon several times to relax the material and make it easier to inflate. For more accurate result, they were asked to blow up the balloon 6 times, 3 for normal breath and the other 3 for deep breath. Finally, we simply measure the diameter of the balloon and obtain the volume of their lung capacity through the Moscow's graph. Their height and weight were also recorded for further analysis. There were a total of 20 volunteers participated in this experiment, and they were separated into 2 groups, athlete and non-athlete, according to their exercise habits. In each group, there were 5 females and 5 males. They all aged between 16 to 20 years old. Participants with regular aerobic exercise were defined as athlete, while those without regular exercise were defined as non-athlete.
So, do you think male has higher lung capacity than female?
Yes, because I think male usually do more exercise and then you can.
I think male has higher lung capacity than female.
Yes, That's true. In this interview, 95% of the participants believed that males had higher lung capacity than that of females. It is in line with our experimental result that no matter participants defined it as non-athletic or athletic, males have higher lung capacity than female. It can be shown by the fact that males have higher maximal aerobic power than that of females, since the sex hormone produced in males and females are different. For instance, the dominant sex hormone in male is androgen, while that in female is estrogen. The increase in estrogen levels can increase the fluid retention and blood volume, which affect the gas exchange in the lungs. Therefore, the male's lungs generally hold a larger amount of air than females.
Also, there are some differences between athletic and non-athletic groups. In average, the tidal and vital capacity of athletes are larger than that of non-athletes. The result shows that athletes have around 4.5 liters of vital capacity, which is 0.5 larger than that of non-athletes. Due to the regular exercise, the muscles of respiration such as diaphragm and intercostal muscles was strengthened. According to a journal done by Andrew Alefrati, both expiratory and inspiratory muscles play an active role in breathing during exercise. Their action is highly coordinated within each single breath, and this process can help to train the respiratory muscles. The diaphragm will become thicker and stronger, which can help the breathing of athletes become more effective. Due to their strong respiratory muscles, generally, athletes have higher lung capacity than non-athletes.
Once the height of the volunteers were arranged in ascending order, it is clear that the taller the volunteers, the higher their lung capacity are. One possible reason is that taller people generally have larger thoracic size, which means the size of lungs are also larger. Also, according to a research conducted in 2009, taller people have greater oxygen consumption. They have higher lung capacity to fulfill the needs of oxygen.
In conclusion, the result proves that male has larger lung capacity than female, athlete has larger lung capacity than non-athlete, and people who taller has higher lung capacity than the shortest one. Doing regular aerobic exercise is possible to increase lung capacity.
However, we have found that there were limitations in this experiment. For example, the sample size was too small. Also, even though some participants were defined as athletes, their lung capacity could still vary a lot, since the intensity and the frequency of doing exercise were different. Therefore, our experimental result may not be accurate.
But why? Why do we need to care about lung capacity?
Actually, several studies have found that the decrease in lung function may increase the risk of having heart failure or cardiovascular diseases. Most participants in those research did not realize that degeneration happened in the arteries could also negatively affect the lungs' function. Nowadays, doctors analyze patient lung capacity and pace of inhalation or exhalation to diagnose respiratory diseases. That's the reason why lung capacity is able to evaluate your health. If you constantly encounter shortness of breath during exercise or in daily life, you should better to have a body check as soon as possible. So after watching this video, I hope you can get a better understanding about lung capacity.
I see. I never thought that lung capacity is that useful.
So what are we waiting for? We should be doing exercise now. Let's go!
Oh.